In 1869, Dmitri Mendeleev created the first periodic table. His periodic table was put in order by increasing atomic mass. The neat thing that Mendeleev did when he made his periodic table was that he actually used it to predict properties of elements that at his time had not been discovered. In 1913, Henry Moseley fixed Mendeleev's problem with his periodic table by putting it in order by atomic number. Remember from our last video that atomic number is the number of protons for any element, and it is its unique identity. Now, when we put the elements in order by atomic number, that's when Mendeleev realized that there was a repeating pattern in the elements' properties, both chemical and physical. This led to the creation of the periodic law. The periodic law says that when elements are put in order by increasing atomic number, there's a repeatable, predictable pattern in the way that they will react in terms of their chemical properties and physical properties. The elements that are in the same group have the same number of valence electrons, therefore they have similar chemical properties. And the elements that are in the same period have the same number of energy levels, therefore they tend to be similar in size. One of the things you'll need to know on the periodic table on the milestone is to be able to look at the periodic table and identify if an element is a metal, non-metal, or metalloid. You'll notice on the slide that we have the one from your resources, and we've got a color-coded one. On your periodic table that we use in class and the one on our wall, you have this solid, bold line that I'm outlining in red. All of the elements to the left of that line are metals, with the exception of hydrogen. All of the elements to the right of that line are nonmetals. And elements who have two sides that sit on that bold line are metalloids, with the exception of aluminum, as we can see in our color-coded pattern here. Aluminum is a metal, as well as all of the others that are to the left of that solid bold line. Hydrogen is the only non-metal on the other side of the periodic table, and we will see later why hydrogen's on the left. So, starting with a little bit about the metallic character for each of our elements. We're going to start with our metals, since they tend to make up most of the elements on the periodic table. You can see at the image at the bottom that all of the metals but they're in that purplish gray color on the table, and we know that they are all to the left of that bold line. Metals, as we learned back in Unit 2 earlier in the semester, are good conductors of heat and electricity. All of the metals are solid except for mercury, who happens to be a liquid at room temperature. Metals are malleable, which means they can be pounded into sheets. That's how we're able to make coins. And metals are ductile, which means they can be bent or drawn into wires. That's how we're able to make jewelry. On the opposite side of the periodic table, we have our nonmetals. And our nonmetals have properties that are opposite of the metals. Think of them as not metals. They live to the right of that bold line, with the exception of hydrogen, who's on the wrong side. And nonmetals, since their properties are opposite of metals, are poor conductors of heat and electricity. That makes them fairly good insulators. Nonmetals tend to have low boiling points and low melting points, and most of them are gases at room temperature. The few that are not a gas at room temperature tend to be brittle, which means that they're going to shatter or crumble if they're hit with a hammer. Last but not least, we have our metalloids, and our metalloids are the elements that have two sides that sit on that bold line. Of course, we already discussed that aluminum is an exception. If you've ever seen aluminum foil, you know that it is a metal. Metalloids are properties that fall in between your metals and your nonmetals, and their properties tend to vary with temperature. For example, silicon is a great insulator at low temperatures, and germanium, the element just below it, is a good conductor at high temperature. So now that we've identified where on the periodic table you can find different elements, let's introduce some terminology about different parts of the periodic table. The first part of the periodic table I want to talk about are your groups. We've already mentioned that elements in the same group have the same number of valence electrons. And if you remember back from the first lesson in this unit, our groups are numbered along the top of the periodic table, and they go up and down on the periodic table. So think about it this way. Whenever you work in a group on a project, your grade goes up or down. So our groups are our columns. They are the vertical columns on the periodic table. Conversely, the periods, where the periodic table gets its name from, are the horizontal rows. They are the things that go across the periodic table, and the elements that are in the same period have the same number of energy levels. If we were to draw Bohr's model, this will show us how many rings that we would end up using for our electrons to live in. So each group or column is called a family or a group. Those names are interchangeable, and every column has its own unique name. The thing that you have to remember about each of the columns is that the valence electrons are the same, therefore their properties are the same. This is what the periodic law states. It says that the patterns repeat as we add atomic number when we put them in order by the atomic number. This is our periodic law. So a little bit about each of the families. You're going to need to know where they are on the periodic table and be able to know their names. So our group 1 is the alkali metals. Think of it as the AM group. They're the first group on the periodic table. Your alkali metals are elements that have one valence electron. They have that one electron in that outer energy level. And since they only have one in that outer energy level, they tend to lose it to form a positive 1 charge. Hydrogen, who happens to be the only non-metal in that group, can also form a negative 1 charge, but it can form a positive 1 as well. With hydrogen being the only non-metal, it's also the only gas at room temperature, and all of the others are solids. But all of the elements in group 1 are extremely reactive. Group 1 elements tend to be one of the 2 most reactive groups on the periodic table. So group 2 is your alkaline earth metals. It's the second group, therefore it has 2 parts to its name. Your alkaline earth metals all have 2 valence electrons. Remember, that last number of the group number tells me the number of valence. Since it only has 2 valence electrons, it always forms a +2 charge. It's going to lose those outer 2 electrons to drop down an energy level to help become stable. All of the elements in group 2 tend to be solid at room temperature. Group 13 to 12, that middle part of the periodic table, are called your transition metals. With the exception of mercury, they all are solid, and mercury is the only metal on the entire table who is a liquid at room temperature. Transition metals form a variety of charge and form multiple ions or oxidation states. We tend not to play too much with them in physical science and leave them for chemistry. And I already said that about mercury and being solid. So group 13, the next several groups get their name from the lead element in the group. So if I look at group 13 is headed up by boron. So that family's name is the boron family. And since it is group 13, I know that it has 3 valence electrons. Since it has 3 valence electrons, it's going to tend to give them away to become stable. And it's positive to give, therefore it tends to form a positive 3 charge. The boron family is the first time where we see a metalloid in one of our groups. With the exception of boron, all of the others are metal, and they all are solid at room temperature. Next group, group 14, again, it gets its name from the lead element in its group, the carbon family. The carbon family in group 14 has 4 valence electrons, and it can form either a +4 or a -4 charge or ion, depending on if it is a metal or a non-metal. This group happens to be a mixture of metalloids, nonmetals, and metals, and they all are solid at room temperature. Group 15, again, gets its name from its lead element. It's the nitrogen family. It has 5 valence electrons, and since it has 5, it's going to take too much energy to give away all 5 of those electrons, so it will go out and steal 3 to become stable. We will see in the next unit that elements are trying to get an octet. They're trying to get to 8, and one way they do this is by losing electrons to drop down an energy level, and another way is by gaining them. So everything in group 15 always forms a -3 ion. Label this on your periodic table to help remind you. It's a mixture of metals, metalloids, and nonmetals. Nitrogen is a gas, and all of the others are solid at room temperature. Group 16 is the last of the groups that gets the name from the lead element, and it happens to be called the oxygen family. It has 6 valence electrons, and since it is 2 away from being stable, those elements tend to gain 2 electrons and steal them. Therefore, they form a -2 charge. Oxygen is a gas, and all of the others are solids at room temperature. Group 17 is your halogen family. The halogen family has 7 valence electrons. They are 1 electron away from being stable, therefore they always form a -1 charge. They are primarily nonmetals, with astatine being a metalloid depending on which book you reference. And group 17 is the other most reactive group on the periodic table. Group 17 and 1 are both 1 away from being stable, therefore they tend to easily form compounds and bonds. Fluorine and chlorine are gases, bromine is a liquid, and iodine and astatine are solid at room temperatures. Last but not least is group 18. Group 18 are known as the noble gases. They are the nobles of the periodic table, and they do not interact with any of the other elements. This means that they don't form bonds. All of them have a full outer energy level, with most of them having 8 valence electrons. Helium is the exception because it doesn't even have 8 electrons. It has 2, but if we remember back to Bohr's model, his first energy level could only hold 2 electrons. Therefore, helium does have a full energy level with just its 2 electrons. Most of them do not form any types of compounds at all. That's why they are called the noble gases. They are all nonmetals, and they're all gases at room temperature. Now, I've stressed the phases as we went through each of the groups, but you'll notice that the vast majority of our periodic table are solids. If you happen to be in the classroom looking at this, you'll notice that the elements on the wall that are gases tend to be red. Now, just because it's a red letter on the wall does not mean that it's a noble gas. Only noble gases are in group 18. There are only 2 liquids on the periodic table, and those tend to be blue on our periodic table on the wall in the classroom. That would be bromine, Br, and mercury, Hg. And you'll also notice the one that you use as a reference sheet and the one on our wall in the classroom have different numbers of elements. We have all 118 on ours, and the one that we use for physical science does not. But the extra elements that are missing on the physical science table are the ones that are man-made, which is why their symbols are clear or outlined. So a couple other group names you might hear elements referred to as. First is these tall groups that are color-coded pink. Those are called the representative elements. They're given that name because they represent the vast majority of the elements on the periodic table. The middle part, we already know, are called our transition metals. And these bottom 2 rows that have been pulled out are called the inner transition metals. Your inner transition metals actually live within the transition metals, hence their name. They are metals, and they are to the left of that bold line that's on our periodic table. Now, if you haven't done so, pull out your periodic table and label the number of valence electrons that each of the elements have. Remember, we know the valence electrons by looking at the last number in the group number. So group 1 has 1, group 2 has 2, 13 has 3, 14 has 4, 15 has 5, 16 has 6, 17 has 7, and 18 has 8. Anytime you're given a periodic table for a quiz or test, use a marker and label the top of it with the number of valence electrons. This will help you as we're getting further into the chemistry content. Now, your periodic table that we use for class has the periods labeled. Remember, our periods are the rows on the periodic table, and they tell us the number of energy levels that any element has. The periods are always numbered from top to bottom. So if I look right here in period 3, magnesium and sodium, if I were to draw Bohr's model, would each have 3 sets of rings for the electrons to go on. Also notice at the bottom of the page where it's trying to show that selenium should be squeezed in beside La, and element 90 should fall after element 89. This is showing that our inner transition metals fit within the transition metals. So to determine the number of energy levels that any element has, I just need to see which period it's on. So elements that are in that first row, hydrogen and helium, only have 1 energy level, therefore they only get 1 circle. Elements in period 2 have 2, 3 have 3, 4 have 4, 5 has 5, 6 has 6, and 7 has 7. All you have to do is look at the label on the side of your periodic table to determine the number of rings that any Bohr's model should have, the number of energy levels that the elements, the electrons, can go into. So, kind of summarizing, for the physical science milestone, you will have to know where to find your metals, nonmetals, and metalloids. That bold line gives you a dead giveaway. But if you like putting things in alphabetical order, metals are on the left, then your metalloids, followed by your nonmetals. Happens to be alphabetical order. You also need to know the group names. So group 1 is alkali metals, group 2, alkaline earth metals, 13 through 16 are named after their lead element, boron family, carbon family, nitrogen family, oxygen family. I'm forgetting somebody. Group 17 is the halogens, and 18 is your noble gases. Don't forget that your group numbers tell you your number of valence electrons, and they have the same number of valence electrons, therefore they have the same chemical characteristic levels. So take a moment and review some of the stuff from our first lesson. If I'm looking at chlorine, I have to remember that this number on the top is called my atomic number, and it tells me the number of protons and electrons. The thing in the center is my symbol. And it's always written first letter uppercase, second letter lowercase. The third thing is the name. Remember, the names and the symbols don't always match. And the last thing is our average atomic mass. Now remember, if I wanted to find my neutrons, I would have to round this to a whole number because we can't have part of a neutron. So if I were to try and define my neutrons for chlorine, I would take my average atomic mass and I would round it to 35, and I would subtract from it the number on the top. So 35 minus 17 tells me that I have 18 neutrons. Take a moment and pull out your periodic table and see if you can answer these questions that are embedded in the PowerPoint before Ms. Rains does them in the video. So pause the video now. So using the elements that have been identified on the table shown on the slide, which of the elements is a halogen? So I have to remember that halogens are in group 17. In group 17, the only element who has been identified is fluorine. Question number 2, which element has 4 valence electrons? So remember my valence electrons, I can just number my tall groups. 1, 2, 3, 4, 5, 6, 7, 8. That tells me my valence electrons. So the only one who has 4 would be carbon, which is an alkaline earth metal with 4 energy levels. So alkaline earth metals, it's got 2 parts to its name, therefore it has to be group 2. But I need to figure out which one of these 3 in group 2 has 4 energy levels. Therefore, I have to remember that the energy levels are related to my periods. So I would count my periods down, and I would see that the only element in group 2 that has 4 energy levels is calcium. Next, which element forms a -1 charge? If you've not done so already, take a moment to label your periodic table with the charge, the ion, or the oxidation state that each of these elements form. You could hear any of those three words. So group 1 is +1, group 2 is +2, group 13 is +3, group 14 is plus or -4, group 15 is -3, 16 is -2, 17 is -1, and 18 has no charge because they don't form a bond. So the element that forms a -1 charge has to be fluorine, the halogen. Which element forms a +1 charge? Well, our positive elements are on the left side of the table. It's easier to start with the positives than it is the negatives. So lithium is the only one identified with a +1 charge. So, guys, make certain you label your table as you're trying to complete the activities for class. Add your valence electrons and the charge to the top of each of the columns. Feel free to color code your periodic table to identify your metals, your metalloids, and nonmetals. This is your resource as we go throughout the course. This is it for today for physical science, so have a nice day. Remember, your teacher is available in Google Meets if you've got any questions.